Alright, we're going to take a look at this map here and see if we can come to some kind of conclusion about what this map actually shows. This is the air map of the world, 1945, I believe. We're going to zoom in on this scale here and take a look at what it shows. It's got two scales. It has this latitude scale and it has a longitude scale, which is this funky thing down here. Latitude scale, it's pretty straightforward. This is 200 miles, 400 miles, 600 miles, 800 miles, and everything that measures can be, oops, figure out how to use my computer. You use that scale to measure along the lines of latitude, or actually along the longitudinal lines. You're measuring latitude along these meridians here. So the distance, this is called the azimuthal equidistant map. Azimuthal equidistant map. Everything radiating out from the center. These are the azimuth directions from the North Pole. Everything is an equidistant distance from the North Pole on this map, the same as it is on the globe. So Kansas City right here, if you were to measure from the North Pole to Kansas City, you're going to get the exact same distance as you would on a globe. You measure from the North Pole to, where are we over here? Africa, Niamey, wherever this is, Togo over here. This distance from the North Pole out here, you could use that scale down here at the bottom, measure it with that scale, and that'll tell you how many miles it was on these meridians from the North Pole to any other destination on the Earth, or between two places on the Earth, as long as you're measuring in this direction from north to south, no matter which way you're going, north to south, that's the scale. All the miles are equal, they're equidistant. But when you're measuring this way across the meridians longitudinally, you're measuring on the latitude lines per se, those distances are not equidistant. Everything gets bigger as you get further away from the North Pole, because this map is a projection of the globe. At the North Pole here, down to the equator even, they're fairly similar, but you look at this scale, you see that these curves start curving out towards the equator here. This line right here represents the equator, and then they rapidly start to curve out further, and it only goes down to 50 degrees south, as somebody pointed out. The reasons why it doesn't go past 50 degrees south, I said maybe because it wouldn't fit on the map, which it wouldn't, but also the map only goes really to 50 degrees. Past that, you don't have anything to measure. So that's one reason why it's not on there. As you can see, half of South America is cut off on this map. But regardless, let's take a look at the scale again. So every one of these lines across this scale represents a line of latitude on the Earth. So the North Pole is here, 80 degrees north, 70 degrees north. Go ahead and zoom in on this again. The numbers here on this diagonal line, it shows number of miles in each 10 degrees of longitude. Now that's on each of these lines of latitude. So here at the equator, 10 degrees of longitude is equal to 692 miles. Up here at 80 degrees north, it's 120 miles for 10 degrees of longitude. These are statute miles. So you see that gets larger as you get towards the equator here. 120, 237, 347, 445, all the way up to 692. But once you pass the equator, it starts going back down. Here, 10 degrees south is the same as 10 degrees north. It's 681 miles, then 650, then 600, then 531. And it's going to continue until you get to the South Pole, which will be, again, zero. But what you'll end up with is a line that basically stretches on to infinity. So the miles, the actual distance on the map that represents a mile in longitude, going, not longitude, but longitudinally, is getting bigger. The miles are getting bigger on this map. It's not because it's different in the south than it is in the north. It's because it's a projection of a globe on a flat piece of paper. So what you're looking at right here at the equator, if we can find the equator, I can't see, 10 degrees. I think this is the equator right here. If I can find some numbers. No, I'm sorry, the equator's down here. This line is the equator right there, Ecuador. So on that line, going around in a circle, from one line of latitude, or sorry, one meridian to the 10 degrees over here, 40 to 50, or that's 30, I guess, 40 to 30. So between there and there, it tells you at the equator, that's 692 miles. 692 miles right here. Right here, it's 581. I can't read that scale. Here, it is, no, I'm sorry, I'm reading all those wrong. I need to zoom in again. Okay, so on the equator, where was my equator go? Here it is. All right, so 10 degrees on the equator, 681 miles. Okay, then 650. It's a little bit less because you're going up the globe here. Then over here we have 600, then 531. This is 531 miles. Well, that makes sense. This is smaller than this is, right? So it's going to go up. Once you get to the equator, I lost my equator again. This is it? Yeah. Once you get to the equator, like I said, that's going to be 692 miles. But then once you get past the equator, this 10 degrees right here is less. It's 681 miles. This 10 degrees here, 650 miles. Now this is 600 miles, but it's bigger. It's bigger miles. This is 531 miles. And then this big old line here is 445 miles. And it just keeps getting bigger as you go further south, but the actual distance is getting smaller. That's what's wrong with this map. That's why this map is not an accurate projection. It is an accurate projection, but it's not an accurate representation of the actual shape of the Earth. This map does not give you accurate distances this direction. It only gives you accurate distances this direction without having to use that funky scale to figure out what these distances are. And the shapes of the continents are distorted because of this. That's why we lost Australia. There it is. That's why Australia is all stretched out wide, because it's distended. It's wider in this projection than it actually is on the surface of the Earth. And this is not, it's not rocket science. This map does not accurately portray the sizes and distances on the Earth. If it was a flat Earth, you could draw a flat map and everything could be drawn to scale, one scale, not a separate scale for going this way, and the going this way is another scale. So I don't know why that's so hard to understand.